So today we're hitting our changing of the subject of our equation and substitution. So let us get the whiteboard. All right. Changing the subject of our equation. So if I give you a nice simple equation, B equals U plus A times T. So this is an equation from science. So particularly from physics, it's one of your equations for motion, for linear motion. That sort of thing you don't need to worry about. Now, if I say to you, change the subject to be U, what am I actually asking you for? I'm actually asking you to get this equation to become U equals something, something, something. Well, in this scenario, that's not very difficult. I want to try and get U by itself, so I need to move this. And to get this whole thing to the other side, it's currently being added, which means when we move it to the other side, we do the inverse operation, which is subtraction. So it's V minus AT equals U. And I'm a happy man. Very easy. What about if I ask for the subject to be T? So from initially the V equals U plus AT. Well, that means I need to try and isolate this. Well, not too difficult again, but it's a little bit more. So we first got to isolate this term with a T in. So take the U over, V minus U equals A times T. And then we're going to get T by itself. So essentially, we can treat A just like a normal coefficient. So when dealing with that, I'm going to have to divide the A. So I divide this whole thing by A and that whole thing by A. Please note, I'm dividing the whole side. Not just the V, not just the U, but both of them. So they cancel over there, and then I'm left with this equation as V minus U over A equals T. And once again, I'm a happy man. Now, you might be saying to yourself, I can kind of understand what he's doing, but why? Why am I concerning myself with dealing with all of these letters, changing them around? For what purpose? Well, the purpose comes in with substitution. So if I give you the following, V equals U plus AT, and I tell you that V is 20, A is 2, T is 5, and I need to find U. There are two ways of doing this. Either you substitute in and then solve for U, or solve for U and then substitute in. So because I like to be complete, I'm going to show you both methods. The one of the methods you would have seen already. So if I sub in V, I get 20 equals U plus A, which is 2, and T, which is 5. So I can multiply these. So I get 20 equals u plus 10. Take the 10 over, becomes a minus. So 20 minus 10 is u. So u is just 10. Great. And that's the way that most of you will probably do it. So you would sub in the values, and then you can work with numbers far easier than you can work with letters because you're more used to it. Or you could rearrange it first. So I need to make u the subject of the equation. So I therefore have v minus at equals u. This we've already come across from our very first example. We sub in our values, 20 minus 2 times 5 equals u. Plug that into a calculator or work it out in your head or on paper, whatever. 2 times 5 is 10. 20 minus 10 is 10. Done. Both of them give you the exact same answer, which we're expecting because it's the same thing. So why do you have to manipulate? So changing this equation is part of a skill that we need to know, because when you get to more complicated maths, you very well possibly might have to take stuff over, refactorize, cancel, divide, do a whole range of things. And this changing the subject of the equation is how we practice manipulating equations. What about the other one that we did? So we did v equals u plus at, and I said to you, v was 20, u was 10, our a was 2, and we have to find t. Now from our previous question, we know that t is 5, because I'm using the exact same values. Does it matter if it's 20 equals v or v equals 20? No, not at all. So once again, I can use either method. So v is 20, u is 10, a is 2 times t. So 20 equals 10 plus 2t. Take the 10 over, we get 10 left because it's 20 minus 10 equals 2t. Divide by 2 on both sides because this is a multiplication. It cancels, and we're left with t equaling 5, which is good because we know it's meant to equal that. What about on this side? Well, on this side, we could manipulate first. So v minus u equals at. We divide by a on both sides. They cancel. So t is v minus u over a. Sub in my values over 20 minus 10 all over 2. So 20 minus 10 is 10, over 2 is 5. So t is 5. And that is exactly what we expected, that it would get you the exact same answer. Now, you may notice that the actual calculation here is easier because you can literally just tap it into a calculator and get your answer. It's one step. But then you have to work with all of these letters here beforehand. So you need to be able to work with both options because the question will depend on which option you choose. Any questions so far? Hopefully that was not too quick for you guys and you're following what I'm doing. All right, good stuff. So let me give you a bit of a tougher question. So what about if I say, so this is kinetic energy, but just so that we don't have a confusion of notation, I'm just going to put it as E. So kinetic energy equals a half mv squared. Again, another science formula for the energy of motion, your kinetic energy. I say to you, I want you to change the subject to be V. So take a little bit of time, try and work that out. All right, now that you've had some time, let's go through this. So we are trying to isolate V. We're trying to get V by itself. We are unable to have more than one V in the equation if V is the subject. So one of the options that has been given, V equals E over a half mv. This is a problem because there's a V and there's a V. This is the one we want. This is the one we want to get rid of. All right, so this is one term. So there's nothing to add or subtract to either side, which means we're now going to have to multiply or divide. So this half m is like a coefficient of v squared. So we can divide the half m to the other side. So we get E over a half m, which equals v squared. Now, if you divide by a half, that is the same as timesing by 2. And we know this because of your tip and times rule. So that's actually 2e over m, which equals v squared. Now, that change from the half to the 2, not direly critical, but it just makes it neater. The more important part is, how do I get v by itself here? Well, what's the problem? What is stopping me from having v now? Or what is stopping me is the squared. And as I've told you already, to move stuff to the other side, you've got to use the inverse operation. Well, what's the inverse of squaring something? Well, it is square rooting something. So therefore, the square root and the square cancel. And you're left with the square root of 2e over m that equals v. And that is your final answer. So this was a closer option, except this v was not meant to be divided through. That v was meant to stay up here, to stay as a squared, and then you square root. Now, if I say to you, given that E is 200, M is 20, calculate V, you could again either sub it into the beginning or sub it into the formula that you have already, because we are now trying to find V. So V equals the square root of 2e over m, which is the square root of 2 times 200 over 20. Therefore, 2 can cancel with the 20 to become 10. This 10 can cancel with 1 0 there. And then you are left with the square root of 20, which on your calculator will give you 2 root 5. And that is a perfectly acceptable answer.